Hello, my name is Mr. Asprey and this is the complete A-level maths revision sheet. I've made this sheet for the EDEXCEL exam board, though I'm sure it will be useful for other exam boards as well. And I've tried to cover all the topics that you will need for paper 3. The one topic that I definitely haven't covered is the large data set. I've got a sheet on that, and I've also got a sheet on pure maths, and this sheet as well all can be found in my Google Drive, and the link is in the description. Now in this video I'm going to go over why I've put everything on this sheet, and I'm going to explain each and every part and also let you know some top tips along the way. I think having a good revision sheet is a really important part of the revision process. I made sure I made one for my GCSEs, my A-levels, and even when I went to university to get my degree. It's a great way of consolidating all the things that you need, condensing it into one manageable sheet, and then having that as the thing that you revise for and look for whilst you're doing your revision. If you find this useful, then please do like and subscribe. Let's get into the maths. Sampling. It's not the most exciting topic, I know, but you need to know all the different types. So we'll start off with simple random sampling. Now, what you need to remember here is always state that you've used a random number generator to generate the people on your sample. Systematic sampling, this is where we number the population and then we select every given interval. For example, you could select every 10th person, so you get the 10th person, 20th, 30th, etc. Quota sampling, this is when we set a predetermined number of people with a given characteristic. So for example, you might say, I'm going to select 30 people over the age of 60, and once you've found those people, then you don't select any more people over the age of 60. Opportunity sampling, this is also known as convenience sampling, or pretty much like lazy sampling essentially, because you just select the most conveniently available people to you. Census, this is where we survey the whole population, and the downsides of this is that it is time consuming and it's also expensive. Stratified sampling, this is where we split the population into groups, and the sample size of a given group will be proportionate to that group's size. So the more people in that group, the more people that will be in the sample. Okay, moving on, we're going to go down to averages and spread, and we're going to look at the mean. So the mean is just simply x bar, which is the sum of the x's over n. The interquartile range is given in your formula booklet, but I'm sure you know this already. It's the upper quartile minus the lower quartile, or Q3 minus Q1. Standard deviation. Now this is the square root of the variance, and there are a few ways that we can write this. The most common one is the square root of x, the sum of the x squares over n, minus the mean squared. Now that's given in your formula booklet, and so is this one, which is the the square root of the sum of the x minus x bars all squared over n, also known as the square root of sxx over n. So do look in your formula booklet and understand where those formulas are and what they mean. Coding, so this is when we apply a code to every bit of data in our data set, and what we need to remember is how that affects the mean and the standard deviation. The mean is affected by the multiplication, division, and also the addition and subtraction, whereas the standard deviation is only affected by division and multiplication. Box plots, you have the smallest value is the whisper on the left. This next one is the lower quartile. In the middle, that line is the median. Then we have the upper quartile, and then we have the largest value, and then we have the outliers, which will be outside of the box plot, and they will be just little crosses there. Okay, moving on to interpolation. So what I like to do for these questions is I like to draw myself a little number line, and I have the class width at the top, so for example between 100 centimeters and 120, and I have the frequency, so how many people at the start of the class was 16, at the end there was 21. And then if you need to find the median, and we know the median is in the 18th person, then you do the gap between m and 100, so m minus 100, over the whole gap of the class, which is 120 minus 100, and we set that equal to the gap between 18 and 16, and that's over the gap between 21 and 16. And we get m is equal to 108 in this example. Okay, histograms. We should know this from GCSE. Area is proportional to frequency, and frequency density is frequency over class width. Okay, moving on to correlation and regression. The different types, well, that's a positive correlation because it's going upwards from left to right. This is a negative one because it's going downwards from left to right. This is no correlation because it's just all over the place. And this one's strong because all the data points are close to the regression line. And this one's weak because they are further away from the regression line. Okay, now what is regression? Well, we have two variables. We have the independent variable, also known as the explanatory variable, and this is on the x-axis. And the dependent variable, also known as the response variable, that's on the y-axis. For example, the x-axis you would have something like temperature, and the y-axis you'd have something like ice cream sales. And that's because the temperature is independent of ice cream sales. So it doesn't get hotter just because you buy yourself a Magnum. But the ice cream cells are dependent on the temperature, because when it does get hot, then you are more likely to buy a Magnum. And what's the equation of the regression? It's just a linear equation, so y is equal to a plus bx. Extrapolation, what does that mean? That's when we incorrectly make predictions outside of the data range. So we predict something that's going to happen, let's say in the future, whereas we only have data for a set time period. So that would be extrapolating by extending the regression line on and then just making conclusions based off that. Okay, let's swap over. And we are on non-linear models. Now this is the strangest topic because it comes up in pure maths and statistics. You have a model like this, and what you want to do is log both sides, rearrange it to get it into a y equals mx plus c. Here you can see I've highlighted the variables log y and log x, and that means that n is the gradient and it means that log a is the intercept. And there's another exponential model which when you log, you get that log y is the variable and x is the other variable, and log b is therefore the gradient and log k is the intercept. Probability, we need set notation, and we need to know that n is the intersection. I'm sure you know that already. U is the union, and a dash means not a, not. And the epsilon means the universal set, and the e means that it is an element of. So if we say that 2 exists in or is an element of the set A, that means that 2 is in A. Let's move on. So formulae. So here I've highlighted these green because they are in your formula book. I do recommend learning them anyhow. The probability of the union occurring is equal to the probability of A plus probability of B minus the probability of the intersection. And the probability of B given A, conditional probability that is the probability of the intersection over the probability of A. So whatever is given, so A is given here, so A goes on the bottom. Independence, so two things are independent if their probabilities multiplied together equals their intersection. And two things are mutually exclusive, and that is if they have no intersection, they don't overlap. Okay, moving on to distributions, random variables. So this is where you have those questions where there's like a table and it gives you some probabilities, and essentially all you need to know is that the probabilities of all the outcomes will add up to 1. Binomial distribution. The notation is that x is squiggly line, capital B, NP, where n is the number of trials and p is the probability of success. Conditions, and these are really important to remember. There has to be a fixed number of independent trials. So they have to be independent of one another for us to be able to use the binomial distribution. And there must be 2 outcomes, so the probability of p and the probability of not p, 1 minus p. Okay, normal distribution. How is that notated? X normally distributed mu sigma squared. So mu is the mean and sigma is the standard deviation. The conditions, it has to be continuous data. So the probability of an actual individual given point is 0. Okay, which is, I know it's quite hard to conceptually understand that, but because it's continuous, it could take an infinite number of values, so each probability on its own is infinitely small, so it's 0. I know, it's crazy, blows my mind. But that's why when you do the normal distribution, you don't need to write x is greater than or equal to 5, you just write x is greater than 5. It has to be symmetrical. The mean, the median and the mode are all in the same place, right in the middle. And you also need to have an understanding that about 68% of the data lies within one standard deviation away from the mean, and 95% of the data lies within 2 standard deviations of the mean. So what this means is if you are more than 2 standard deviations away from the mean, then you are an outlier, essentially. The normal distribution for the z values is given as z is normally distributed 0, 1 with 0 mean and 1 standard deviation. And you can use the z distribution and the formula z is equal to x minus mu over sigma to work out mu and sigma if you're not given those in your in the question. So that's a really common question to find mu and sigma, so make sure you know how to do that skill. Okay, approximating the binomial distribution using the normal. So the notation is that the new distribution is normally distributed with mean of np and variance of np times 1 minus p. Now those 2 bits there are actually given in your formula booklet, so do have a look at where they are. So you don't need to remember them as such, but you do need to understand that they are what you use when you approximate the normal distribution. And that means that the standard deviation you use that you're going to put in your calculator is going to be root np 1 minus p. And the condition that you need to has to happen in order for you to approximate is that n has to be large and p has to be close to 0.5. Continuity correction. Now lots of people lose marks here because they're not quite sure what this means or when to apply it. But it's always when you are approximating the binomial using the normal. And let's give an example. Let's say that you want in your binomial distribution to be greater than 5. Now because binomial is discrete, it only takes integer values, that means that what you need is 6 or more. And because the normal distribution takes decimal values or any value, 6 or more is the same as saying greater than 5.5, because anything greater than 5.5 will round up to 6 and that will give us the success we need. And here's another example. Let's say the binomial you're looking for x is less than or equal to 3. So that means 3 or less. And what rounds to 3 or less? Well, anything under 3.5 will round to 3 or less. So therefore, the normal distribution there, you have to correct it and use y is less than 3.5. Okay, let's move on. Okay, moving on to hypothesis tests, everyone's worst nightmare. But never fear, I'm going to simplify it for you. Binomial. One-tailed test, we write h0 is equal to, probability is equal to some value. And then h1, we say the probability is either less than that value or greater than, depending on what we're testing. Two-tailed test, we say the null hypothesis is the same as it was before, but the alternative hypothesis is that it's not equal to 0.3. And don't forget to split the significance level once you have identified it's a two-tailed test. Right, the conclusions. This is where people make a lot of mistakes. If it's less likely, so the probability that you've calculated by testing your test statistic, if it's less likely than the significance level, then it's a very rare event and it's not likely to occur with the old probability. That means we must reject the old probability, h0, and we must accept the fact that the probability has changed. Whereas if the test statistic is more than the significance level, then that means that it's a really likely event to happen. And if it's really likely to happen, then there's no reason for us to accept the claim that the probability has changed. No, we don't. We accept h0, the probability has stayed the same as it always has. Okay, critical regions. This is the set of values where we reject H0. So essentially they're the set of values where we say that there has been a change and the claim is correct. The actual significance level, this is the probability that the value will be in the critical region. So we basically test to see what the chances are for values which are in the critical region. Or another way of thinking about it alternatively is it's the probability that H0 is rejected incorrectly. Okay, now let's test for correlation. So the notation that we need to use is the letter rho. Now it looks pretty much like a P anyway, so you'll probably get away with just writing P. It's just a little bit more slanted. And the critical values which we need to do a correlation hypothesis testing can be found in the formula booklet on page 37. Now there's lots of statistical tables in the formula book, so it's a good idea to just remember the number 37 so you could turn to it straight away and save yourself some time. Now the conclusions. You'll have to get a test statistic value for your correlation, let's call that R, and you take the modulus of that, and if that's greater than the critical value you find in your formula booklet, then that means that your data is very well correlated. So we reject the null hypothesis and we accept that there is correlation. Or should I say that we say there is enough evidence to suggest correlation. Remember, always use that term, evidence to suggest. And if the modulus of your correlation value is less than the critical value, then that means that we accept H0 because it's not correlated enough for us to say that there's been a change. Now we take the modulus because the critical values are always positive in your formula booklet, so if you're testing for negative correlation, you must turn it into a positive value. Okay, moving on to normal. Now this is really important, this. When you are doing a normal hypothesis test, you get given a sample, which is the value n, and your new distribution, x squiggly bar on top, is normally distributed mu sigma squared over n, which means the standard deviation which you put into your calculator is the old standard deviation divided by root n. And let's go to random definitions. And let's start with stats. Discrete, data that only takes certain values. Continuous, this is data that could take an infinite set of different values, such as time or temperature, whereas discrete is something like shoe size, which only has certain values it can take. A uniform distribution is when all outcomes are equally likely. And I'm going to transition very smoothly into mechanics here, and I'm sticky with random definitions. This is a seamless switch, I know. It's very smooth, and look at this, smooth. That means no friction, and it also means that the tension will be the same on either side of the pulley. So if you've got a smooth pulley, it means we can assume the tension is the same on either side. Right, inextendable. This means that acceleration will be the same on both sides. So you often see this in a truck and trailer problem. And the rod, if it's inextensible, then it means that the acceleration of the car and the truck will be the same. Light means we could ignore weight. G is 9.8 meters per second to the -2, unless otherwise stated. Sometimes they randomly just, I don't know why they do this, but they just say, in this question, use G as 10. So watch out for that, because you might lose marks if you overlook that. Uniform, in mechanics, this means that weight acts through the center. So you often see this on moments questions where you have a rod, and it means you draw the weight directly in the middle of the rod. Speed is the magnitude of velocity. Distance is the magnitude of displacement, and bearings are measured clockwise from north. Okay, switch it up. Constant acceleration, velocity time graphs. I'm sure you know this already, but distance is the area under the curve or graph, and acceleration is the gradient. SUVATs, I absolutely love a good SUVAT. They're brilliant. You're not told what the letters stand for. S is displacement, U is initial velocity, V is final velocity, A is acceleration, and T is time. You are given the SUVATs. They're on page 8 of your formula booklet. Make sure you know where to find them. S equals ut plus a half at squared. S is equal to a half u plus v times t. S is equal to Vt minus a half At squared. V is equal to U plus At, and V squared is equal to U squared plus 2As. There it is. I think I will remember those for the rest of my life. Variable acceleration, PVA, Patrick Van Aanholt is how I remember that, Crystal Palace left back. What does it stand for? Position, velocity, acceleration. And if you put them in that order, then you can differentiate down, and you can, of course, integrate up. Moving on to forces, Newton's second law is the most important equation of mechanics, I would say. The sum of the forces equals mass times by acceleration. That's the one we use for the majority of our questions with forces. Weight is the mass times by gravity. Friction is always less than or equal to mu r, where mu is the coefficient of friction. And remember, it's always less than or equal to, because if there is an object just on the floor and it doesn't need to exert friction, then it won't maximize its frictional force. But if it is slipping or on the point of slipping, or it is in motion, then it will equal mr because it will be using its maximum force. Okay, tension, you draw your arrows in like that, and thrust, you draw them like that, or essentially thrust is like negative tension. So if you ever get a negative value for your tension, it just means that the object is in thrust rather than tension. Reactional forces act perpendicularly to the point of contact. Resultant force is the sum of the forces acting on an object. And a system is in equilibrium if the sum of the forces is equal to 0. Moments. A moment is force multiplied by perpendicular distance. An object is in equilibrium if the clockwise moments are equal to the anti-clockwise moments. And a object, or a rod for example, is about to tilt if a reactional force is equal to 0. So I've drawn a little diagram here. You've got a rod lying there and it's being propped up by two reactional forces. And if the one on the left there, for example, is found to be 0, then it means the system is on the point of tipping. Okay, vectors, we have xi plus yj, and the units are I is the easterly direction, j is the northerly direction. Magnitude we have is the square root of the two components squared and added together. And directional value, I would always recommend drawing a quick sketch when working with vectors, as to not to just rely solely upon the tan minus 1 formula. You kind of want to get an idea of what the angle is and what direction it's going in, so always do a little sketch. If it's tricky, draw picky. Projectiles, we got maximum height is when the velocity in the northern direction or in the j direction is 0, and we have no air resistance, so the acceleration in the horizontal direction is always 0. I hope you found that useful. If you did, please do like and subscribe and share. Bye for now.